This will be the analog input example. We'll be using a PWM cable that's been modified with this end cut off and two bare wires exposed that we'll connect to the battery. The black will go to the bottom of the battery, the white will go to the top of the battery, and you can find a battery in a mouse or some other battery. The battery should not be more than 5 volts for this exercise. We are back to our Cumulative Robot project. I have Visual Studio Code, the shuffleboard, and the driver station opened up. We're going to get to the WPI-libc++ class documentation. We're going to go to the class list in the FRC namespace. We're going to look for analog input. It's right here. We're going to grab this header, go to our H file, and add this. And back over here, we're going to construct an analog input object. We're going to be using some of these items here. We're going to use get value, which returns an integer. We're also going to get voltage, which returns a double, which is a real number. The integer is a whole number. Get value will return the value of the analog to digital converter. If you remember from our earlier lesson, this is a 12-bit converter which has 2 raised to the 12th states. So the count value would be from 0 to 4095. That's a total of 4096 states. Get voltage, the WPI library will scale that scale from 0 to 4096 to a voltage from 0 to 5 volts. Returning back to our VS Code and driver station and shuffleboard, we have, we see this error again, discrepancy between the documentation and what's happening in the library. Let's go down here and create another object. Analog input is the object type, and we'll just call it AI. Why not? We're going to put this on channel 0 on the front panel of the RoboRio, so squiggly brace 0. We have that. We're going to come down here. We're going to declare two variables. One will be an integer. It will be AI raw, which is the raw analog to digital converter value. This is just for demonstration. Typically you would not use this in an application. We'll just go ahead and initialize this variable to 0. We're going to create a double, a real number, for the voltage. And we'll just initialize the initial value at 0.0. Control S to save this. Go to robot.ppp. Let's go into the teleop mode. We're going to go AI raw equals to AI.get value, which is here. This is the analog. This is the ADC value, or analog to digital converter value. And the voltage will be, we'll read it with a different method. It says get voltage. We have this. So now we've read it and stored it into 2 variables. We'll go back up to robot periodic and print those out and steal these values. AI raw. There's the voltage. Generally what we're interested in is the voltage, but it may depend on your application. Going to build it. Now we're going to deploy it. going to hit my little garbage can here and clean this up a little bit. Back to the driver station on the shuffleboard. We're in teleop mode. We're going to enable it. And here we have the raw ADC values and the voltage. So on a scale of 4,200 is about maybe 5%. 5% of 5 volts is about a quarter volt here. I'm going to grab the 2 pins and just short them together with my fingers. There you go, that brought it a little closer to 0. What you're seeing here is a little bit of noise and other stuff that's being picked up, introduced to the front end of the analog to digital converter. So it's really hard to get to 0. I'm going to now attach the battery to the wires with my hands. So we got 1.4 volts on the battery, which is a converter count of 1,000. On a scale of 4096 steps, we're at a 1,165. 1.42 volts for this little AAA battery, and that's how you make yourself a little voltmeter. That's it for this exercise.